This is Michael from Blue Sky Bio. I'd like to welcome everybody who's joining us for the video training session during lunchtime. Hope everybody has their sandwiches and you're munching away. We're going to get started in just a minute. We're going to allow another minute for people to finish logging in and joining the presentation. Okay, I think we could get started. You should be able to hear me and see my screen. You're encouraged to ask questions during the presentation to make sure everything's as clear as possible. So you could go ahead and type any questions into the chat box on the right-hand side of the video screen. The CE credits for the presentation will be sent via email within around a week's time, but please make sure to enter your details into the webinar attendance form. There are links in the comments section underneath the video window. There's a link to the form. You could go ahead and click on it, put your details into the form, and then we will be able to send you the CE credit. The focus of the presentation today is model-based surgical guide fabrication in Blue Sky Plan. We're focusing in specifically on model-based surgical guide fabrication. We're not going to be discussing the second option of digital design, but we will be discussing what the difference is and the advantages of the model-based surgical guide fabrication. The agenda for the presentation, I'm going to mention very briefly recent software updates that we released in Blue Sky Plan, the advantages of the model-based technique, which is what we're going to be focusing on in today's presentation, the process flow, which I call a 2-minute design, but in actuality, you'll see it's a couple of clicks. Everything has been configured and updated and modified with new intelligence built into the software to make the process as easy and quick and simple as possible. So we're going to see that. We're also going to see the process is slightly different if you're using another drill system. If you're not using the Blue Sky Bio drills, but if you're using another drill system, then we'll discuss that process as well. Just as a comment, the software and the surgical guides could be used with all implant systems and all guided surgical kits. So you can make surgical guides for all systems. We're going to discuss importing a model, which we're assuming for this presentation that you have general background and you're able to use the software on a pretty good basis and on a pretty good level. But we're going to be discussing importing a model because if it's done properly, it's a quick and accurate process. And I think it's important to touch on them. So we're going to be demonstrating that as well and pointing out where you could get more information and support regarding the process. Just a minute regarding our recent software updates. If anybody hasn't yet downloaded the software could be downloaded at no cost from our website at blueskyplan.com. The latest version that we have, there's 3.29.7. If you have an older version, you could go ahead and download the new one, install it on top of what you have. It will use your existing license. You won't need a new license. You don't need to uninstall the previous version. Just go ahead and install on top of that. Our most recent updates includes automatic nerve detection. With one click, the software will mark and draw your nerve. We also have an automatic panoramic curve detection. When you load the case, the software will automatically draw an accurate and intelligent panoramic curve. For both jaws, you're able to modify it if you like and save it in the software. You could also put in a third curve if you like, maybe by the occlusion, and all of that is saved in the software and you could toggle between them. We also have advanced tooth segmentation to extract teeth, and we have specialized modes, which we're going to touch on now during the presentation as well. Before we do that, let's discuss for a minute the advantages of the model-based technique. There's really two techniques for guide fabrication that you could use with Blue Sky Plan. One is the model-based technique, which is we're going to be discussing. The second is digitally designing the surgical guide. Now, the obvious question is, why do you need two different techniques? The advantages of the model-based technique is, first of all, it's very easy to visualize, to confirm, and to understand the process and what you're looking at. You get the model with a post, you put the metal cylinder on top of it, you do your own vacuum press. Everything is very clear, very obvious, very intuitive. You could see exactly where the metal cylinder is going to be. Everything is very clear and easy to understand. The second reason, which is the most important reason, is that it could be done with a non-biograde material. Why is that important? It's important because 3D printers that print biograde material are significantly more expensive. That's the situation for now. It could be that in coming time we expect that the prices will go down, the material costs will go down, and then there wouldn't be much of a difference between using this technique and the other technique. But right now, you could get a printer that prints non-FDA approved material. You could print the model with the post. Because none of that material is going into the patient's mouth, there's no problem with it. You'll then do a vacuum press or suck down on top of it with the metal cylinder. We'll take a look at that. And you can make your surgical guide. So it's a good option for in-house surgical guide fabrication, whether you're a dentist or whether you're a lab. If you want, you could get a cheap, relatively cheap 3D printer for a few $1,000s, print your own models and posts, and make your own surgical guides that way. The third advantage, I was just looking at a case yesterday, is tight spaces. If you don't have a lot of room between teeth where you're going to be placing the implant, when you digitally design the surgical guide, part of the surgical template will be surrounding the metal cylinder. So that takes up a bit more width for the printed material that's going around the metal cylinder. And in a tight space, that could be a disadvantage. When you're using the model-based approach, you're going to have the model with the post. The post is going to hold the metal cylinder, but from the inside of the metal cylinder and not from the outside. So that's actually going to be an advantage in terms of saving spaces, especially for tight cases. Okay, we are going to jump over to the software. And like I mentioned, please don't hesitate to ask any questions. Obviously, the point is to have a good understanding of the process. So if anything's unclear, you want me to repeat anything, or if you have any questions, just type it into the QA box. Okay, the process starts from the point where we have a completed treatment plan and we have an imported model. As I mentioned, we're going to discuss the process of importing the model, but we're going to do that at the end of the presentation. So here we see our model. It's already been aligned with our CT scan, and we have the implants in place. Okay, so after the treatment planning is completed, we go ahead and import the model, and the model is used for the surgical guide fabrication process. Why do we need a model? Just a word on why we need a model. The answer is because optical scans or intraoral scans are more accurate than CT scans, both in terms of their innate accuracy and also because a CT scan, for those of you who are familiar, have the density threshold slider on the bottom, which affects the shape of the patient's anatomy, of the model. You could think of it as a grayscale, and you could adjust that scale, and it's going to adjust the size and the shape of what we're dealing with. With an optical or intraoral scan, there's no gray involved. There's no different shades of gray. It's either black or white. It's either there or it's not there. It's much more defined. It's a yes or a no, and not anything in between. So the surgical guides are fabricated or designed based on the model and not the CT scan. Okay, so we're at the point where we have the model imported, we have the treatment plan completed, and what do? We go over to the guide panel. This is how our guide panel is supposed to look. In the software, there are 3 different modes. There's a viewing mode, a normal mode, and an advanced mode. The viewing mode is for what it is. It's for viewing cases. You can't treatment plan. Advanced gives you all the full-blown functionality for guide fabrication in the software. And normal is what we're using now for treatment planning and for simplified guide fabrication. And when you're using the normal mode, your guide fabrication panel is going to look like this. There's no numbers, there's no settings. Everything is here with buttons. The first thing that we're going to do, basically, we're just going to click on the buttons that we want, and we're going to see what happens. Okay, so the direct cut settings for printed model. Let's go ahead and enlarge our screen here. And we can also turn off our CT scan. Okay, and we click direct cut settings for printed model, which is what we're going to be using here. What do we see happen automatically is we now have, in addition to the implants, we have what are essentially abutments, but they're in this situation posts. And we have the brown cylinders that have been added. Everything has been added with the proper configuration to support a metal cylinder at the proper location, angle, and depth. The post is slightly smaller than the internal diameter of the metal cylinder. The brown cylinders that we see around the yellow posts are there as a shelf to support the metal cylinder at the correct height. And essentially what would be going for printing is what we see now on the screen. It would be the model, would be the yellow posts, and the brown shelves. Okay, so the software, all the settings and all the configuration have been set to hold the metal cylinder, to work with the proper drills. It's all there. Now we have a couple of other buttons here. Let's take a look at what the other buttons are for. The second button that we have is to close the model. As you could see here, we're dealing with an intraoral scan. If we send this to a 3D printer, then we'd have a bit of a problem printing an intraoral scan. The inside needs to be closed and a base needs to be added. So if you're dealing with an optical scan and it already has the inside and already has the base, you just skip the close model button and you're good to go. If you're dealing with an intraoral scan, then you need to close the model. Closing the model takes around, you press the button, it takes around a minute or so to process. I did it before the presentation. And this is what we get when we close the model. It's filled in, it's the same model filled in. Okay, so if you're using an intraoral scan, you press close model and it's closed. Now, on to the verify button. In some situations, based on the location of the implant, you might see that the shelf doesn't clear the model. You have parts of the model that's overlapping the shelf. So what's going to happen when you put the model onto the post, it's not going to sit completely and properly. The anatomy or the model is going to interfere with the positioning of it, and that's problematic. So we built in a button called Verify that takes care of this automatically. And I'm going to switch back to our previous mode and watch what's going to happen when we click the Verify button. Watch what's going to happen. Watch what's going to happen in our cross-section slice. And I'll ruin it for you a little bit, but what's going to happen is that the implant's going to stay in the correct position. It's not going to move. The implant's not going to move, but what we're going to see is that the abutment and the software guide tube is going to adjust itself automatically so that the shelf is not interfering with the model. The model is not interfering with the shelf. We press the Verify button, and it says your abutment and drill guide have been modified for model clearance. And we can see in our 3D view that the shelf and the post have been elongated to properly support the metal cylinder. Okay, the implant didn't move. It didn't affect where the osteotomy is going to be. It didn't affect where the implant is going to be. It just affected where the metal cylinder is going to be. And the software also did the necessary calculations so that when we get to the part, the relevant parts, which should be used in just a minute, it will indicate for you the parts based on the adjusted abutment and shelf. Okay, so all of that is already considered by the software and does not need to be considered by the user. So we just discussed the Verify button again, to review, what the verify button does is make sure there's full clearance of the shelf from the model, and there's no interference, there's no future interference between the patient's anatomy and the metal cylinder. Okay, that's our verify button. Export exports what we see as an STL file. Again, there's no settings, there's no buttons or numbers or anything like that. You press the export button. The software, all it does is asks you where you want to save the file, the STL file, and it does the preparation for you. It exports as an STL file exactly what needs to be exported, the model, the shelf, and the post, and that STL file is ready to go for 3D printing. Okay, so you give it a name, just like you would save a Word file or any other file. You give it a name, you choose where you want it saved, and that's it. And we'd have our STL file. Moving along on our buttons, we have the report button. And what the report button is, it automatically generates a report for you. The report contains relevant and valuable information, including the parts that should be used, including the drill depth, and including images of your case. So you want to take it along with you, you want to save in the patient's file. All the data is processed by the software, created into a PDF file. You could save, you could print, and all of that is done automatically with the click of the report button. The last button that we have here is the order parts button. You press the order parts button, the Blue Sky Bio website opens up with the relevant parts added to your shopping cart, with the relevant quantities and everything. So you can modify the quantities. If you already have a drill or you have tubes, you could exit out and remove it. But with the order parts button, all the parts that are relevant for the case are added to your shopping cart, and you could go ahead and place the order. Okay, so I'm going to summarize the process flow. The first part of the process flow is pressing the direct cut settings for printed model. You press it, the tube and the shelf is added, it's done. Close model is what we said. If you're using an intraoral scan, it needs to be closed and have a base to it, so it could go for printing. If you're using a scan of a model that already has a base, is already closed, you just skip the button. Verify will adjust the shelf height and the abutment and the post length if there's any interference between the shelf and between the model of the patient's anatomy. Export, with the export click, you save the STL file, everything that needs to go for printing. Report gives you that nice PDF file, and order parts allows you to order the parts. And really, that's it. It's as simple as that. There's no buttons, there's no manual modification. I'm sorry, there are buttons, but there are no numbers. There's no manual modifications that need to be made. You go down the list, click, 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 save, export, and you're good to go. Responding to a question, can you take a CT scan of the model? You could, and the software functionality allows it. So it's possible in the software, but it's not recommended. It's not recommended because of what we discussed earlier, the downsides of a CT scan. One being that it's inaccurate, it's less accurate than a model optical scan or an intraoral scan. And two is that the CT scan has your shades of gray, and the question of what the exact threshold that should be used is there as well. So while it's possible, it's not recommended. Okay, so that's our process flow. If you're using the Blue Sky Bio drills, using the Blue Sky Bio metal cylinders, everything's pre-programmed into the software. Click, 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 you're done. So even though it's called a 2-minute process, it's actually, in many situations, less than 2-minute process. Now, what happens if, for whatever reason, you're not using Blue Sky Bio drills? So the first thing that needs to be done is you need to know which metal cylinders you're using. Okay, we have a list on our website of around 50 different metal cylinders, and you need to know the right one to use for the drill that you're going to be using. It needs to be slightly larger. It needs to be slightly larger than the drill so that it could pass through the drill. It should be around a little less than 1/10 of a millimeter larger than the outside of the drill. But once you know the outside measurement of your drill, you could check which tube has the proper inner diameter, and you figure out which tube you're going to be using. Okay? And this is the list that's on the Blue Sky Bio website for the tubes. Now, with that information, you could go ahead and do the process. Now, what would be different in the process flow if you're not using the Blue Sky Bio drills? The difference would be like this. You press the direct cut settings for printed model button anyway. After you press the button, then you jump over to your implant list. And here's where you need to make 2 manual modifications. The first one is that the abutment diameter needs to be 1/10 of a millimeter less than the internal diameter of the metal cylinder. Conceptually, it needs to be a little bit thinner than the inside of the metal cylinder, so that the metal cylinder could go onto it and the post could support it. So if you're using a metal cylinder that has an internal diameter of 5 millimeters, for example, then your diameter for the abutment will be 4.9 millimeters. The second modification that needs to be done is that the guide hole diameter, which in our situation is the brown shelf, should be set to be 1/10 of a millimeter less than the post. And we could see right over here what happened. We made the post wider to support a wider metal cylinder, and we made the shelf wider to support a wider metal cylinder. So the 2 changes that need to be made to review are changing the abutment, which is our post's diameter, and changing the guide hole diameter as well. And these should be done for all of the implants. You could go one by one and make those 2 modifications. Okay, once you have that done, you jump back to your model, you jump back to your guide panel, and the rest of the process is the same. To review, if you're not using Blue Sky Bio drills, then you take the inside of the metal cylinder, you change the abutment diameter to be 1/10 of a millimeter less than the internal diameter of the metal cylinder. You change the guide hole diameter to be 1/10 of a millimeter less than the abutment diameter, and you go back to the guide panel and you continue the process. Okay, just taking a look at some of the questions that came in here. Okay. As you may or may not know, models need to be imported in STL format. Okay, we can't import models that aren't in an STL format. So unfortunately, whatever needs to be done or the proper equipment should be used, whether it's an intraoral scanner or an optical scanner, should be used to get into STL format. We have 2 different length drills. We have a short and a long. Depending on the treatment plan and the implants, you could use the short if that works. If it does work, then on our website, when you click order parts, then the short drill will be placed there. Otherwise, then the longer drill needs to be used. Okay. Moving along. So we've discussed the process flow for Blue Sky Bio drills. We've discussed the modification of the process flow. If you're not using Blue Sky Bio drills, the next item on the agenda we're going to discuss is importing a model, and then we're going to discuss places where you can see more information and get support. Let's go ahead and turn off our model. Let's turn on our CT scan. When you're doing the importation of the model after the treatment plan is complete, you could hide the implant, the abutment, and the software guide tube. There's no need for that. Before doing the import, you could use tools such as isolate or cut to make sure there's clear visualization of the teeth of the osteotomy, of the occlusion. If there is an opposing jaw, then recommend removing it so you have clear access and visualization. And once you have that done, before you do the importation process, you want to go to the presets, make sure you're using surfaces, which is the bottommost option. You could raise your density threshold. What you really need to see are the teeth. So if there is any sort of interfering material, then you could raise the density threshold, and that will often help clear it up. Once you see the 3D CT scan as clearly as possible, you go to File, Import STL Model. Okay, you select the STL file that you want to import. And the software throws the model into the 3D view. You could go, it's recommended to go to points and align. There are other importation techniques if you're doing a model based on another model, whatever, but the general principle to do the importation and do the alignment is points and then clicking on align. The software is going to open up for us the CT scan of the patient and the STL model side by side, so that we'll be able to see both of them together. Okay, in these views, we could use any of the functionality that we have in the software to rotate, to zoom in, to zoom out, as we like. What we're going to be doing is we're going to be placing at least 5 points in locations that we could clearly identify in both of the scans. When we want to place a point, we hold down the Shift key and left click. Okay, the order doesn't matter. It doesn't matter if you do all of them on the CT scan and then do all of them on the model. It doesn't matter if you go back and forth. It doesn't matter the order that they're placed. But you want to place a good amount of points. You want to disperse them. You want to disperse them throughout. You want to place them as accurately as possible in both of the scans. More points are better, not worse. So if you want to toss in a couple of extra points, then you could do that. And you want to disperse them mesial distal, buccal lingual. Okay, once you have your points placed, you go ahead and press the OK button. And we see how the merge is. If we turn on the model outline, then we could look in our different views, and we could see the merge and how it fits. You want to look in the areas where there are teeth. In the areas where there's just soft tissue, then there's an expected discrepancy between the CT scan and the model due to the soft tissue. And you could go around the arch and making sure the outline is tight around the teeth. You can also check in the axial view. As you get closer and closer to the occlusion, you want to see that model outline, once again, grabbing and going around the teeth as accurately as possible. If you're not happy with the alignment, then try doing it again, add more points, disperse them better, place them more accurately, and the vast majority of the time that will rectify any issues. If the case is a high scatter case or completely edentulous, then it's recommended to use a scan appliance with markers during the CT scan. We're not going to go into that now in detail, but please be aware of that. If the patient has a lot of metal restorations in their mouth, which causes scatter, or it's completely edentulous, then a CT scan appliance should be worn during the time of the CT scan. So that's the process of importing the model. There's more functionality. You're able to adjust it manually. You're able to adjust it using a widget, change the points of rotation. You're even able to adjust it almost pixel by pixel using the arrows on your keyboard. We're not going to go into these functionalities now, but you should know they exist. And if you like, you could watch a video about them, or you could contact me and we could go over them. But the general protocol is to use the points, use a line, disperse the points, place them as accurately as possible, and the alignment will be successful. Just to review, before doing that, make sure you're in the surfaces mode. Presets surfaces. And you could also raise the density threshold, and you could clean up the CT scan a little bit, or remove the opposing arch, and that will help with visualization. The STL file, the optical scan, has more detail. That is why it's recommended for surgical guide fabrication, and that's why CT scan is not recommended. How much is it going to affect the surgical guide? Case by case, depending on the quality of the CT scan, it could vary. So it's, if you want the maximum accuracy, maximum results, then you should go for doing the process based on the optical scan or the intraoral scan, basically an STL file of the model. Okay. Before wrapping up with information and support, we're going to do a little quick review. Okay, we discussed, just to summarize, the advantages of the model technique. The main advantage is that you could use non-FDA approved material, which makes the printer and it makes the materials cheaper, much more affordable. If you want to put one in your office, it becomes much more of a reasonable and less costly option. Another advantage is you see the model, you see the post, everything is visually there. Let's take a look for a second at actually how the remainder of the process looks. There's an example case on the website, which we're going to discuss. But the process continues that after, you could see here how it looks when it's printed. You have the post and you have the shelf. Everything is clear. Then you put the metal cylinder that fits directly onto the post and is held by the shelf. And then you could do a thermoplast or a suck down or vacuum press. It picks up the metal cylinder. It creates the surgical guide. We could see the underside of the surgical guide and how it fits the anatomy of the patient based on the model. And that's the rest of the procedure after it's printed. So the advantages are you could use the non-FDA material, the non-FDA printer. everything is clear, everything is there to see, and also in tighter spaces, it's often advantageous. The process flow in terms of creating the model with the posts. First of all, if you don't see your guide panel looking like this, make sure you're in the normal mode. If you don't see this at all, make sure you're downloading and using the latest version of the software. Direct cut settings for printed model sets everything up with the posts and with the shelf. Close model, if you're using an intraoral scan, it closes it and adds a base. Verify, make sure that the shelf doesn't conflict with the model and the future metal cylinder won't be problematic with the patient's anatomy. Export saves the STL file. Report generates the nice report with all the relevant information that we saw earlier. And order parts brings it up on the Blue Sky Bio website so you could order the relevant parts. If you're not using Blue Sky Bio parts, then the two modifications that you need to do after pressing direct cut settings for printed model, you jump over to the implant list, you change the diameter of the abutment. It should be 1/10 of a millimeter smaller than the metal cylinder, so the metal cylinder could sit nicely on it. And the guide tube hole diameter should be slightly 1/10 of a millimeter smaller than the post, than the abutment, so that it tightly grabs the post and creates the shelf around it. Those are the two modifications if you're using a different guided surgical kit. Okay, and then we show the process of importing the model. Okay, regarding additional information and support. If you, on the Blue Sky Bio website, let's bring it up a sec. When you click on software, then it brings up everything that's related to guided surgery. You have your guide tube store, and you also have your in-house guide fabrication, which is what we are discussing now. If you scroll down, you have information here regarding the process flow. You also have information where you could print the model with the posts. If you don't have access to your own printer, then for a very reasonable cost, $35, $40, $50, you could have it printed out for you. The contact information and links exist here. Specific information regarding model-based surgical guides, which is what we're dealing with, is here. When you click on it, it shows the model, the sample case. It shows the process flow. There's a bunch of QA going, frequently asked questions that's listed here. And you also have links here to the guide tube store and to getting the functionality for the STL export and some videos explaining a lot of what we discussed here. If you have questions in general, you could always contact me. Email is a great option, plan@blueskybio.com. I'm also available via phone. My phone number is here, contact, and it also appears on the support page of the Blue Sky Bio website. So if you have questions regarding that. If you're looking to get a 3D printer, then you want to get one that's as close, as accurate as possible. It should be it should print at around 20 or 30 microns, which is 0.02 millimeters or 0.03 millimeters. It should be as accurate as possible. Some printers that I've heard about that reach that level of accuracy is the Titan 1. That one, I think, has very good reviews in terms of cost, in terms of print speed, and in terms of accuracy. Some other ones, I heard of one from Formlab, the Form 1 printer. So those are two printing options as well. But if you're getting a 3D printer, then you want to look at this, at the slice thickness, at the accuracy level. You want something that's around 20 microns. Okay, that pretty much concludes the presentation. If you have questions, enter them into the QA box before we wrap up. Make sure, please, to enter your details into the webinar attendance form. The attendance form, there's a link for the attendance form in the comments section under the video screens. The CE credit will be sent to you in around 1 week's time via email. If you don't receive it by then you can email plan@blueskybio.com. You could use that email address for any questions as well. Regarding scanners, the intraoral scanners are very accurate. The optical scanners, you want something that reaches around 20 microns. Okay, the more accurate the entire process is, the more accurate the results are going to be. So you want the scanner to be as accurate as possible. You want the printer to be as accurate as possible. And of course, we build the software to meet those levels of accuracy. So the higher level that the process is done on, then the better the results obviously are going to be. Okay, so that wraps it up. I'll bring my contact details back onto the screen. Here's the phone number. If you have questions, emails plan@blueskybio.com. And I would like to thank everybody for attending. We have another presentation pretty much on the same topic next week at 12 noon Pacific time. If you know anybody on the West Coast that wants to attend, or if you want to watch it again, the presentation is being recorded and will be on YouTube and on the Blue Sky Bio website in the very near future. So if you want to watch it or reference it as well. Again, this is Michael from Blue Sky Bio. I'm the Director of Guided Surgery, and I'd like to thank everybody for attending, and I hope the rest of your day is fantastic.